Good morning, everyone. So, today we will start again with the same topic, that is 8051 programming in C. So, up till now, we have covered in previous session regarding data types of C programming. Now, today we will be seeing regarding the IO programming in 8051 C. So there are two ways to access the I/O ports in 8051 using C programming. In this we will be learning the way to access SFR, that is special function register, and next is the access bit addressable RAM. So this we are going to study today in this topic. So first is how to access the SFR. The way to access SFR, here we will be using the name of SFR and we will be using the general purpose header file, that is reg51.h. This is the header file for 8051 microcontroller. Now if you want to access your SFR, that is your IO port, you can directly write here P1, that is port 1, is equal to 0 cross 55 and reg51.h is necessary over here, and this SFR data type which you are declaring by yourself is in the form of hexadecimal data only. So directly you can declare your SFR by writing SFR P1 is equal to 0 cross 90. So whenever you are defining SFR, it will access the special function register, which is a part of IO port. So it will access the SFR directly by writing the SFR data type before the port 1. So this way, at this time you can directly write down SFR P1 is equal to 0 cross 90 instead of writing the header file and then defining the port 1. Your header file is not necessary. Whenever you are directly writing the SFR, it will directly access your data from IO port. So this is about how to access the SFR, that is special function register. Now this is the structure of 256 byte RAM space which is available to you. This 256 byte of RAM space is available to you in form of different sections, that is bank 0, bank 1, bank 2 and bank 3 up till 00 to 1FH. That much space is occupied by the register bank. The rest of the banks is taking the space 20 to 7FH, and that is the bit addressable range, and the main range from 80H to FFH is occupied by your special function register and internal data memory. So this is the extra space which is occupied by the special function register. Now this is the block diagram of 8051 256 byte RAM, which we have already discussed, that from 00 to 07 bank 0 is occupying the register space, 08 is and 08 to 0F bank 1 register is occupying the space from RAM, 10 to 1H bank 2 is occupying the space, from 1A to 1F, bank 3 is occupying the space. From 20 to 2F, that much space is bit addressable range. It can be accessed by addressing the bit, and 30 to 7F is used by general purpose RAM, that is used by internal data memory. So this way we can have the bifurcation of RAM space which is allotted in 8051 microcontroller. Now the next one is the discussion on how we are accessing this memory space by writing the code. So we discussed that we can access the SFR by writing this syntax of header file and then by defining the data which you want to access or upload on your code. And the second way is directly you can specify SFR instead of calling the header file in the starting of program. So this is the second way of writing the same program for calling SFR. So here it will access the range which is allotted from 80H to FFH. So it will allocate this much space. So this is the way how to access the SFR. Now this is one of the example how to write a C program to toggle all bits of port 0 and port 2 continuously with 8051 microcontroller and having 250 milliseconds of time delay. So the SFR here you will define is 80, 90 and A0. This is for port 0, port 1 and port 2. This is for port 0, port 1 and port 2. You can see here in this block 80 is defined as port 0, 90 is defined as port 1, A0 is defined as port 2 and B0 is defined as port 3. See, a particular register is allotted some memory space in the RAM size, and in that way only you can access them by calling their names or by calling their addresses. So this is the way how to access the data. Same way directly the locations have been called here for calling the SFR ports. So this way now if you want to toggle the data at port 0 and port 2, you can apply the data at this registers, and then after applying some delay you can easily toggle the bits of port 0, port 1 and port 2, and then again you can apply to 50 milliseconds of delay. So this is the way of writing program. This we have already discussed in the initial sessions, that if you want to toggle any bit in your port, then first you apply 55 or you apply AA, and then in after applying delay you toggle them. If you have applied 55, then you have to make it AA, so all bits have been toggled. If you have applied AA, then you have to change it to 55 after applying delay. So this way you can perform the toggling of ports by doing the port toggling bits by applying the delay. So this is the way of accessing the SFR and then making it toggle the bits continuously by applying 250 milliseconds of time delay. Now instead of writing this much of code, you can directly use this code, because this course we have already worked upon, because the computer has already saved these locations as port 0, port 1 and port 2. So no need to specify this much of code whenever you are writing program for toggling of port 0, port 1 and port 2, because already computer knows that port 0, port 1 and port 2 have been allocated the location as 80, 90 and A0. Now same program has been written over here by specifying the header file. Instead of writing the header file, you can ignore it if you want to use directly, because the program will work the same though you have specified the header file for 8051 microcontroller. So this is the way of writing the code if you want to toggle all bits of port 0, port 2 by applying 250 milliseconds of delay. So this is just for our knowledge. Whenever you are defining SFR port 0, port 1, port 2, already locations have been saved in the header file. So instead of writing these three lines, you can directly write down the line for your header file. Header file already has the data of memory locations which are allocated to the respective ports, so it can directly allocate it to the port by just writing or by just defining the header file. So this way, in the header file, this data will be already saved that at which location which register has been specified. This is the data specified in your header file, and this we are loading it in the Kale software whenever we are writing at first time the header file. So this way you can have the access of header file whenever you are specifying any port or any register which you are calling it from the memory space. So this way you can access your data by writing or by calling SFR, or instead of SFR you can have directly the header file. So this header file you will write the data in form of header file in any Word document, and this document you will save with the extension of the header file, and this you will update in your simulation software, so it will be loaded over there and it will work as an header file of 8051 microcontroller. Just whenever you are creating any kind of header file, this is for 8051 microcontroller. Let's take an example. If you are creating a header file for Arduino or for any other programming board, then at that time you need to study the configuration of that board, and then you have to define the connections at which port you are taking, at which register that you need to define, and then you have to add that register data in your document form, and then you have to load that file over the simulation software, so it will directly fetch that data and it will upload it over here. So thank you very much. In the next session, we will start or we will move ahead with the next topic that is related to 8051 programming with C language. So refer this topic and see the code how we have written. Try to implement this code in your Kale Microvision software, and do let me know if you have any doubts. So thank you so much.